It's all around you. In the ground, in the air, in the buildings, in every moment, every interaction, every transaction. It's there. The network. It connects people, information, businesses, and ideas. It's a fundamental part of everyday life. This is how it works. Imagine a transaction, a meeting involving a video presentation, a video conference, and a phone call. Simple, everyday tasks that call into action every facet of the network.
Welcome back. The connections that you wanted are all set up.
Great.
You know everybody here, I think, but I don't believe you've met our CEO. This is Meredith, lead architect for Design One.
Very nice to meet you.
I hear great things about your work. I'm very eager to see what you've got. Where's your team?
Standing by, if I need them. Ladies and gentlemen, Design One Architects presents your new world headquarters.
The internet is evolving into a mesh of connections that enable complex interactions. This visualization of that mesh will act as a map for the transactions we will follow. When the architect plugs in, she connects through the aviation company's local area network or LAN. Then onto the company's digital subscriber line, more commonly known as DSL. A request for video travels out the DSL to the local phone company. The signal enters the network through a DSL access multiplexer, or DSLAM for short. The DSLAM and other technologies are co-located in the CO or central office. Within the CO is a network operations center. It is the traffic control of the network. From the DSLAM, the signal enters into an asynchronous transfer mode switch, known as an ATM switch, and over a metro ring that serves the city. The signal exits the metro ring at her ISP, where it is then routed to the broadband cache server that stores the video. That server responds by sending the high-resolution video back to her laptop. Looking at the path on a single plane, we see the signal leaving the laptop and moving through the DSL modem, then out of the building and into a DSLAM, ATM, IP service switch WDM or wavelength division multiplexer, and onto the metro ring. It leaves the metro ring and goes through a router, and finally reaches the server. Sending the data back just reverses the run. The result? A powerful presentation at the push of a button. That's just the beginning of what the network can do.
Well, it certainly is different.
We feel that we've captured your essence in just the right way.
Now, surely the,
Signature element.
yes, I mean, well, that couldn't be safe.
According to our engineers, absolutely safe. But don't take my word for it. We've partnered with the world's leading architectural engineering firm for just this kind of project. I have the project lead standing by.
Hello.
Good afternoon, David. Everybody's here.
Great.
David, the clients have some questions about safety and stability. Could you just share some of your data with us?
Sure, I got the test results right here. I'll send them.
When the engineer joins the video conference, his voice and video travel across the nation's long-haul network from San Francisco to New York. Since he happens to be connected through a cable modem, his signal enters the network through the cable company's point of presence, or POP. From there, his signal travels across his city's metro ring to a network aggregation point, or NAP, where it joins the eastbound signals from the rest of the San Francisco Bay Area. These aggregated signals enter the long-haul network through a DWDM, where single wavelengths of light are multiplexed together into multiple wavelengths, allowing hundreds of high-bandwidth signals to be squeezed into the same fiber optic cable, doing this all within the optical domain. The volume of data these beams of light can carry is immense. Making sure the traffic gets where it's going are sophisticated optical switching technologies like lambda routers, which provide automatic restoration and rerouting. The lambda routers use micro-electromechanical systems that can redirect the beams of light. So if there's a break in the line anywhere, shown here with a red pulse, the lambda routers instantly reroute traffic along a different path in the optical mesh. When the engineer's signal reaches New York, it enters the local network and is sent to the architect's laptop. Viewing the single plane, we'll run through the signal again. The engineer's data leaves his computer and enters a cable modem, then out of his house and into a CMTS at the POP. Then onto the metro ring. The signal enters the long-haul network through a DWDM. The signal gets routed through a lambda router and then into another DWDM to exit the long-haul network in New York. Then onto the metro ring and finally making it to the architect's laptop. Guaranteeing that all this information arrives simultaneously is the ATM switching layer, which rides above the optical layer and provides quality of service and prioritization. Without it, the network could not handle the huge amount of data being transmitted every day. After all, what good is a voice signal if it doesn't get there on time?
Of course, by its very nature, the drag coefficients of this type of shape are very low. We had to reduce the camber of the lifting surface, but that's simple. Basically, this is the perfect shape.
Thank you very much.
My pleasure.
Thanks, David. We may have some more questions for you. Can I keep you in a holding pattern?
Sure, I'll be in my home office the rest of the day.
What about the regulatory bodies involved? A building like this would certainly bring up some issues.
We thought so as well, so we had our chief legal counsel run it by the FAA and the Planning Commission. Looks like it'll fly. He's in Tokyo right now. Let's check in with him.
Hello?
Hello, Gerald. It's Meredith. I'm here with the committee, and we'd like to hear your thoughts regarding the regulatory bodies.
I'm optimistic. As long as it's brightly lit, the FAA has no concerns. As for the Planning Commission, they're eager to reclaim some public relations momentum.
Thanks, Gerald.
My pleasure.
When our architect calls the lawyer, it sets in motion a chain of events. First, an applet on our computer sends an H323 signal through the telco to a soft switch. The soft switch arranges for the connection. First, it sends the call request over the SS7 network to the International Gateway in Tokyo. Meanwhile, the lawyer's cell phone, because it's on, has already sent a mobility and authentication signal to the Tokyo mobile switch, so the system will know to send all calls to that cell. The gateway responds to soft switch, saying the user has been located and a line is available. At the same time, the Japan gateway reserves bandwidth for the call and tells the other switches on the network. Soft switch sends a signal back to New York saying the line is available. Soft switch opens a voice channel across the network back through the gateway in Tokyo to the mobile switch, which opens a channel to the base station, which sends a signal through the tower to ring the cell phone. When the lawyer picks up the cell phone, the call is connected. Elapsed time, milliseconds. The data leaves the laptop as an H323 signal. It travels to the telco and is routed to the soft switch. The soft switch sends a call request out over the SS7 network. The gateway in Tokyo responds, saying the user has been located. Soft switch sends a signal back to New York saying a line is available and opens a voice channel. The voice goes across the network, through the Tokyo gateway, into the mobile switch, to the base station, through the tower, and to the phone. Real-time voice communications with quality of service enabled by the core.
Well, that's it. What do you think?
One final question. Can it rotate?
Absolutely.
That was a fabulous presentation. Meredith, it's been a very pleasure.
The transaction you have witnessed, as complex as it is just one of millions happening simultaneously on the network. With the power of communication driven by the next generation network, we are starting a journey that seems limitless. All over the world, in every city and town, people and businesses are making phone calls, transferring data, streaming video, and sending files. Communicating. Welcome to the never-ending evolution of communications. At the core of this evolution is Lucent Technologies.